Welcome to the deep dive. Today, we're looking into something really fascinating, maybe a bit concerning, actually.
Definitely concerning.
Yeah, it's about these huge AI models, like ChatGPT. There's this new study showing they can sometimes, well, memorize and even repeat specific bits of the data they were trained on.
And that training data is usually kept totally under wraps, right?
hmm
Secret.
Exactly. So, our mission today is to really unpack this study. It didn't just find this memorization problem. It also found a really clever trick to actually pull that data out.
Sounds like quite the hack.
It does.
Oh.
We're going to look at how they did it, what they found, which is pretty startling, and, what it all means for privacy and AI security going forward.
And this isn't just speculation, right? There's solid research behind this.
Oh, yeah, absolutely. It's all based on a detailed study from researchers at places like Google DeepMind, University of Washington, Berkeley, some really top institutions.
Okay, good. So
Right.
serious work.
Definitely. So, okay, let's start unpacking this. When we say an AI like ChatGPT memorizes data, what does that really mean? Given it's trained on just like unimaginable amounts of text from all over, books, websites.
Right. It sounds a bit like how humans memorize, but it's different. For AI, we call this specific issue extractable memorization.
Extractable memorization.
Yeah, it basically means someone, an outsider, could potentially get the model to spit out data it learned during training.
Yeah.
And critically, without knowing beforehand what data was even in that training set.
So they're fishing blind, but they can still pull stuff out.
Exactly. And the researchers really wanted to measure, how much this happens, what are the privacy risks, how should this affect how we actually build these models?
So it's not just that the model knows something obscure, it's that you can actively make it reveal it.
Precisely. It's about coaxing out data. It wasn't really designed to share that way.
Okay, so it's less about knowing and more about being tricked into revealing things. That sounds, well, tricky to stop.
It is. And, the why is a big question here. Is it just how these large models learn?
Like an unavoidable side effect?
Possibly. The thinking is when they get massive and train on these huge, sometimes repetitive data sets, they can sort of overfit on specific bits. They memorize sequences, especially common ones.
So it might be fundamental, not just a simple bug they can patch.
That seems to be the implication, yeah.
Yeah.
It's a core challenge. And they tested this idea across different models, not just ChatGPT. Things like GPT-Neo, LoMaMat.
Right, some other well-known ones. But ChatGPT is the big one everyone uses. How did they test it specifically? Because it has all those safety layers.
Right. Exactly. ChatGPT is designed differently. It's conversational, and it has what they call alignment processes.
To keep it helpful and harmless.
Supposedly, yeah.
Yeah.
And part of that is to prevent it from just, dumping raw training data that has defenses.
So for the other models, they just generated tons of text and looked for matches.
Pretty much. They generated billions of tokens, words or parts of words, and checked if they showed up verbatim in known training data. But for ChatGPT, they needed a different angle.
Because of those defenses. So how did they get around them? This is the really interesting part, I think.
It really is. They came up with this specific method they called the divergence attack.
Divergence attack. Okay.
And it's actually surprisingly simple in concept. They basically just asked ChatGPT to repeat a single word over and over again.
Just repeat a word, like a repeat poem forever.
Exactly like that. Or repeat the word book forever. Commands like that.
And what happened?
Well, after repeating the word for a while, the model would eventually kind of break character. It would deviate from its usual helpful aligned responses.
And start doing what?
It started spitting out these sequences, chunks of data, that turned out to be directly from its training set.
Wow. So that simple repetitive command somehow bypassed all those complex safety measures.
It seems so. It essentially forced the model out of its safety rails and made it, well, dump parts of its memory.
That's kind of ingenious, actually. And a bit scary. So what did they find using this attack? Did it work well?
Oh, it worked surprisingly well.
Yeah.
The results really showed that these models, including ChatGPT with all its alignment, definitely memorize and can be made to regurgitate training data.
And you mentioned scale earlier.
Right. Here's the kicker. Using just about $200 worth of queries on the standard ChatGPT model GPT 3.5 Turbo, they managed to extract over 10,000 unique verbatim examples of memorized training data.
10,000 examples for $200. That's incredibly efficient.
Frighteningly efficient, yeah. And they estimated that someone really dedicated, with a bigger budget, could pull out vastly more data. It just shows how vulnerable it potentially is.
Okay, so what kind of data are we talking about? Was it just random web text or more specific things?
It was real mixed. They found things like part of a detailed investment research report,
Whoa, okay.
specific Python code snippets, like for doing machine learning tasks,
hmm
and yeah, also just general text that exists word for word out there on the web.
So a real variety. But the code and the report, that sounds like stuff that might not be intended for public view necessarily.
Exactly. Which leads us to the most worrying part, really.
Which is, I have a feeling I know where this is going.
Personal information, PII,
Ah, like names, addresses.
like email addresses, phone numbers,
Yeah.
that kind of thing. They specifically looked for this. They took about 15,000 of these extracted data snippets
Okay.
and used tools like pattern matching and even another AI model to flag anything that looked like PII.
And did they find much?
They did. About 16.9%, let's say nearly 17% of the samples they checked contained what looked like memorized PII.
17%. That's a lot.
It is. And then they went a step further. They tried to verify if this potential PII was actually real PII from the training data, not just the model making stuff up, hallucinate.
Right, because sometimes they just generate plausible-looking nonsense.
Exactly. But here, they found that of the bits that looked like PII, almost 86%, 85.8% to be exact, were confirmed as actual real PII that existed in the training data set.
Oh, wow. So it wasn't just hallucinating addresses. It was recalling real ones it had seen during training.
Correct. Email addresses, phone numbers,
Yeah.
pulled directly from the training data.
That is deeply concerning. Just thinking about privacy implications. If models are trained on vast data sets, maybe including forums or scraped web data,
Or even potentially private documents if not filtered properly.
exactly, then this memorization isn't just an abstract problem, it's a direct privacy risk. It makes you wonder about things like data anonymization during training. Like, is it even enough?
Well, that connects to a really key point the researchers made.
Which is,
They stressed that simply patching this specific exploit, like, okay, maybe stop the model from repeating words indefinitely,
Yeah.
that doesn't solve the root problem.
because the memorization is still there.
Exactly. The model's fundamental tendency to memorize, especially sensitive stuff if it sees it enough, that vulnerability remains. It's not just about this one trick, this one divergence attack.
It's like fixing a leaky faucet when the whole pipe is corroded.
That's a good analogy, yeah. The underlying issue is still there. It points to a deeper, more systemic vulnerability in how these models work, or perhaps how they're trained.
So we need to think bigger than just playing whack-a-mole with specific attacks. It sounds like we need a more fundamental security mindset.
Totally. It requires a holistic approach. You can't just look at the chatbot interface the user sees.
You have to look deeper.
Yeah, you need to scrutinize the foundational model itself, the training data, how the APIs work, the whole system, looking for these less obvious weaknesses.
Like treating the AI system more like traditional software that needs rigorous security auditing.
Precisely. The study really pushes for that perspective. We need systematic security analysis to ensure these things are actually safe and respect privacy, not just powerful.
Okay, so given this big challenge, what do the researchers suggest? Where do we go from here? What are the next steps?
They point to a few key areas. One is improving how training data is handled, specifically deduplication.
Deduplication, making sure the same piece of data isn't repeated over and over.
Exactly. If a model sees the same email address or phone number thousands of times in its training, it's much more likely to memorize it. So cleaning up the data is crucial.
Makes sense. What else?
They also stress needing to understand better how the model's size and capability, its capacity, relates to memorization.
And what did they find there? Do bigger models memorize more?
Generally, yes. The larger, more capable models seem to be more vulnerable to this extractable memorization, which is sort of counterintuitive, maybe. You'd hope bigger means smarter, maybe less prone to rote memorization.
But maybe bigger means more capacity to memorize everything, good and bad.
That could be it. And finally, they call for much better, more robust methods to actually test for this kind of memorization risk, especially before deploying models in areas where privacy is critical.
Right, we need better ways to check for these leaks before they happen.
Definitely. This study really shines a light on a critical aspect of LLMs that clearly needs a lot more attention if we want them to be both powerful and trustworthy.
It really does. It leaves you thinking, doesn't it? If these AI systems are constantly learning, constantly remembering from this ocean of data we feed them, including potentially our own personal stuff, how does that change what private even means anymore in this digital age?
That's the big question, isn't it?
Yeah. It makes you wonder, what other secrets are tucked away inside these incredibly complex systems just waiting for the right or maybe the wrong prompt?